Hello, I am Nuño. I am a professor in the area of signal theory and communications at the Polytechnic University of Valencia in Spain. Now I'm going to explain the equal temperament with n notes. We will review the harmonics, the 12-tone equal temperament, and then we will study the equal temperament with n notes and how they match the first harmonics 3, 5, 7, 9. Then we will consider the Pythagorean tuning and the 53-tone equal temperament with the Holdrian comma by Holda, and the tone, the chromatic and diatonic semitones, and major and minor chords. Finally, some conclusions. These are the first harmonics on the chromatic circle. One octave is 1,200 cents. And these are the 12 notes in 12-tone equal temperament. The distance between two consecutive notes is 100 cents, which is an equal tempered semitone. The just noticeable difference is about 10 cents. That means that generally we can distinguish between two notes which are 10 cents apart, but not if they are, for example, 5 cents apart. Let's consider now an equal temperament with n notes. First, we consider the third harmonic, which is here represented by this central line. And in this axis, we divide the octave in a number of parts from 1 to 250. And in each case, we represent the note which is the nearest one to the third harmonic. For example, if we divide the octave into 12 notes, which is very common, there is one note which is 2 cents below the harmonic 3. If we divide the octave into 17 parts, there is one note which is 4 cents above the harmonic 3. For example, between 12 and 17, there is no point represented here because in those cases, the note which is the nearest one to this harmonic is more than 5 cents apart from the harmonic 3, so it does not appear in the graph. And so on for different number of notes. Here we can see 29, 41, 53, with 53 divisions, there is one note which is practically equal to the third harmonic. We repeat the process with the fifth harmonic. Now the central line is the fifth harmonic, and here we can see different divisions of the octave that are more or less near this harmonic. We can see the 53, the 12 does not appear because the nearest note to that harmonic is more than 5 cents apart from that. For the seventh harmonic, we repeat the process, and also with the ninth harmonic. In this table, we can summarize the results, those divisions of the octave which better approach the first harmonics 3, 5, 7, 9. For example, with 12 divisions, it matches very well the third harmonic, but not 5 or 7. And with 53 notes, it matches very well the third harmonic and very well the fifth harmonic and quite well the seventh harmonic. In the Pythagorean tuning, we consider always the third harmonic. So if we start with note C, we consider its third harmonic, which is G, then its third harmonic, which is D, and so on. Now G has about 702 cents, and in this system, if we go upwards, we find an F sharp, but if we go downwards, we found G flat, which are different. The difference between F sharp and G flat in this system is 23.46 cents, which is called Pythagorean comma. So in this system, there is always 1/5, which is smaller than the others. It is called the Wolf fifth, and it is usually placed between G sharp and E flat, the size being 678.49 cents. If we now consider the harmonic fifth, it is a note E, but is different from this E, the difference being 21.51 cents, which is called Syntonic comma, or also comma of Didymus or Ptolemaic comma. The fifth harmonic, I said that is note E, so with 3 intervals like that, which is a major third, with 3 intervals like that, we have near an octave. but not exactly. The difference being 41.06 cents, and it is called diesis. In 12-tone equal temperament, we divide the octave into 12 equal parts. So now note G has 700 cents, and F sharp and G flat are exactly the same note. So the difference between them is 0 cents. Now the difference between two consecutive notes is 100 cents, which is the equal tempered semitone. The difference between this G and Pythagorean G is about 2 cents. The difference between this F sharp and the Pythagorean F sharp is near 12 cents. And if we consider the fifth harmonic of C, the difference from that note to this E is near 14 cents. If we start with note C and consider the third harmonic is G, then its third harmonic, and so on. If the first note is number 0, G is number 1, D number 2, and so on, then the note number 53 is very close to C, the difference being 3.615 cents. It is called Mercator's comma. In 53-tone equal temperament, we divide the octave into 53 equal parts. In that case, this note is exactly a note C. In this system, the difference between two consecutive notes is 22.64 cents, which is called the Holdrian comma by Holder. The note G in this system is a bit lower compared to the Pythagorean G in 0.068 cents. And this G has 31 Holdrian commas. Now here we represent the commas associated to each note. The octave has 53 Holdrian commas, the tone being the distance, for example, between C and D, 9 commas. The chromatic semitone from C to C sharp, 5 commas, and the diatonic semitone from C sharp to D, 4 commas. Also from B to C. B has 49 commas, plus 4 is 53, which is again C. If we now consider the fifth harmonic is an E, but is not this E. In this system, the nearest note to fifth harmonic is not E, but F flat, the distance being 1.408 cents. So if we want to build a major chord taking into account the fifth harmonic, the best option is C, F flat, G. Similarly, for C minor chord, we would use notes C, D sharp, G. As we saw, the Pythagorean tuning is based on harmonic 3. The 12 equal temperament matches well the harmonic 3, but not 5 or 7. Some of the n-tone equal temperaments that better match the first harmonic were studied. We can select 12 divisions, which is the common, and 53 is very exact. I didn't say it previously, but if we consider more than 120 notes, then the distances to any harmonic is always less than 5 cents. Finally, as conclusion, the 53-tone equal temperament matches well both Pythagorean tuning and just intonation. You can find all the information on the webpage harmonicquill.com. Thank you very much for your attention.